The James Webb Telescope has released 16 coloured images and spectroscopic data, which shows unprecedented power that has already been leaving the entire space industry astounded. If you want to know more about these breathtaking images, you have to stay till the end of the video. But before that, make sure to subscribe and hit the bell icon for notifications. Also like and share more interesting videos like this. The James Webb Telescope is a $10 billion observatory that was successfully launched into space on 25th of December 2021. Ever since it was launched, the world has been waiting to see its first image that, according to NASA, will deliver us new views of the cosmos. While some of the largest ground-based telescopes on Earth have segmented primary mirrors, the James Webb Telescope is the first telescope in space to use the design of a 21-foot or 6.5-meter gold cover mirror, which is far too big to fit inside a rocket fairing. Thus, it had to be folded up for launching. After James Webb successfully made it into space, its 18 hexagonal beryllium mirror segments, which make up the primary mirror, unfolded with extraordinary precision. Aligning each segment onto one smooth, reflecting surface was one of the most important things that the Webb control team had to tackle since the telescope had launched. However, many other alignments, steps and tests are needed before Webb ultimately delivers its new view of the cosmos. Expectations from the James Webb Telescope are indeed astronomical. Based on the evidence so far, it seems like the telescope will live up to the hype. As soon as the Hubble telescope was launched into orbit, scientists knew that they would need better technology to understand the origins of the universe. The Hubble was the first major observatory in outer space that vastly increased our understanding of the cosmos. However, scientists realized that the ever-expanding universe consisted of billions of faraway galaxies was out of the Hubble telescope's reach. Hubble was built to detect visible and ultraviolet light, which went straight into the infrared part of the electromagnetic spectrum. To resolve this problem, the James Webb Telescope has been equipped with infrared detectors that will collect the faint light coming from stars and galaxies a few million years after the Big Bang. With the Webb Telescope, we will be able to see cosmic bodies that are 10 million to 100 million times clearer. The first images sent back by the James Webb Telescope were remarkable. A selfie of the telescope itself, which made the NASA staff go crazy. This selfie taken was not captured by the externally mounted engineering camera, but with a specialized pupil imaging lens inside the telescope's NIR cam, or NIRCam. The NIRCam is one of the unique instruments of the James Webb Telescope that has recently been configured specifically for engineering and alignment purposes, so the Webb team considered it to be a bonus image that gave engineers the assurance that it was successfully receiving light. That is crucial for its ultimate goal of imaging objects in space. While the selfie was considered a bonus image, the first image of space from James Webb was 884406. This star is located approximately 241 light-years away in the constellation of Ursa Major. The image shows a mosaic of 3 stars spread over a black background. RIC image of HD 44406 appeared in 18 places. A mosaic was visible as a result of Webb capturing 1,560 images over the course of 25 hours. The observatory was able to find the stars during the first 6 hours using just 16 images. After discovering the image of the HD 84406, NASA started a procedure called fine phasing of the James Webb Telescope. At the end of the procedure, the telescope's primary mirror moved into focus and directed at a singular star. Here are the details of the images. NASA ESA James Webb Telescope showed the exoplanet WASP-19b, in which atmosphere astronomers have detected titanium oxide in large enough quantities for the first time. Titanium oxide can prevent heat from entering or escaping an atmosphere, leading to a thermal inversion. The temperature is higher in the upper reaches of the atmosphere and lowers further down, the opposite of a normal situation. Astronomers have found a significant difference between gaps in the gas and dust in the disk around 4 young stars using images from space by the James Webb Telescope. The new observations are clear indications that planets with masses several times higher than that of Jupiter have recently formed in the disk. Captured by the James Webb Telescope, this image shows a view of the sky around the bright star Alpha Centauri created by the photographic images forming part of the James Webb. The stars here appear so big because of the scattering of light by telescope optics as well as in the photographic emulsion. James Webb shows the white field of view of the spiral galaxy Messier 83. The image was caused by photographs in red and blue light taken from the James Webb Telescope. An image from NASA ESA James Webb Telescope showing an image of the NGC 1637 about 35 million light-years in the constellation of Eridanus. scientists discovered a Type II supernova in the galaxy and followed it, slowly fading over the following years. The image of the unusual asteroid Lutetia was taken by NASA ESA James Webb Telescope, which is about 100 kilometers across. It seems to be a leftover fragment of the same origin and material that forms Earth, Venus and Mercury. It is now part of a main asteroid belt between the orbits of Mars and Jupiter, but its composition suggests that it was originally much closer to the Sun. The NASA ESA James Webb Telescope shows the planet orbiting the Sun-like star HD 85512 in the southern constellation of Vela. The planet is one of the 16 super-Earths discovered by the near-infrared camera on the James Webb Telescope. The planet is about 3.6 times as massive as the Earth, lies at the edge of the habitable zone around its star, and has liquid water and perhaps the possibility of life. The color composite image of this triplet of galaxies is catalogued as NGC 7173, 7174 and 7176 and is located 106 million light-years away, towards the constellation of Pisces Austrinus. This triplet of galaxies makes up a part of the Hickson compact group, the HGC 90. NGC 7173 and 7176 are elliptical galaxies. NGC 7174 is a spiral galaxy with quite distributed dust lanes and a long twisted tail. This seems to indicate that the two lower galaxies, whose combination bears some resemblance to that of a sleeping baby, are currently interacting. Astronomers have suggested that the three galaxies will finally merge. This ground-based image shows the full extent of the Andromeda Galaxy, also known as Messier 31 or M31. The Andromeda Galaxy appears very large in the sky, several times the size of the full moon. James Webb is designed to make highly detailed observations of much smaller patches of the sky. The Space Telescope's observation of the Andromeda Galaxy shows individual stars and clusters. Wide field-like images in this give a broad overview. This image shows the Herbig Haro surrounding the hard object and the surrounding sky as it is seen from the ground. The sculpted dwarf galaxies are two of the Milky Way's neighboring dwarf galaxies. Like all large galaxies, the Milky Way is thought to have formed from smaller galaxies in the early universe. Spiral galaxies together with irregular galaxies make up approximately 60% of the galaxies in the local universe. However, despite their prevalence, each spiral galaxy is unique. Just like snowflakes, no two are alike. This is demonstrated by the striking Boson spiral galaxy. NGC 6814, whose luminous nucleus and spectacular sweeping arms, rippled with an intricate pattern of red dust, are captured in the NASA ESA James Webb Space Telescope. The latest image of Jupiter was taken by a NASA James Webb Space Technology on February the 25th, 2022. A unique and exciting detail of this snapshot appears at MIT's northern latitude as a bright storm traveling across the planet at 350 miles per hour. Webb shows that the Great Red Spot, rolling counterclockwise in the planet's southern hemisphere, is ploughing into the cloud ahead of it, forming a cascade of white and beige ribbons. Jupiter's icy moon Europa, thought to hold potential ingredients for life, is visible to the left of the gas giant. Many colourful stars are packed close together in this image of the globular cluster NGC 1805, taken by NASA ESA James Webb Space Telescope. Thousands of stars are located near the edge of the Large Magellanic Cloud, a satellite galaxy of our own Milky Way. The stars orbit closely to one another, like bees swarming around a hive. In the dense centre of one of these clusters, stars are 100 to 1,000 times closer together than the nearest star to our Sun, making planetary systems around them unlikely. We all look forward to more groundbreaking discoveries that the James Webb Space Telescope has in store for us. Stay tuned and don't miss anything exciting.